All right, over to you guys.
Thank you, Dalvin. So yeah, today's session, as Jadva already mentioned, is going to be basically regarding C++. And I'm Arnab, and this is my colleague Ankon. And I'm from Nordic Imaging Lab team, and Ankon is from RAII Simulation team. And we both use C++ in our projects and in a professional capacity, basically. So today's talk is going to be based on our experiences and where, how we use it and how the industry use it to write safe code, basically. So yeah, let's start, I guess. Firstly, yeah, let's talk about this an interaction, basically. So you know, unlike other things where you kind of have to like say what is X or Y, we already all know what C++ is. Basically, it's a language that we learn when we were in our universities. It's like one of the oldest language out there. But the thing is that even though it is we learn it so early, I think we see that there are a lot of gaps we have on how it is used for professional settings. So there is the jump from writing just normal C++ code to this kind of professional setting code is kind of big. So we are hoping that we can inject some newness in C++ with our presentation today. So that's why we are calling it the all new C++ thing. Basically, it's a modern. It has a lot of modern feature, but because it remains a backward compatible, that it is going to be familiar to all of us, basically. And the reason to use it is basically it's the most, I've said, the most performant language out there after C. Nobody else can actually beat C++ on that front. And obviously you can, because it has such a small footprint, the ecosystem is everywhere. You can use it for your IoT stuff, your desktop application, even in web. So you can use it to do everything. And because of the requirement and the memory stuff. And because you can use it everywhere, there are a lot of good libraries that exist, third-party libraries and suites of frameworks, basically, that you can use. And we're going to talk about some of them in this meeting, basically. Okay, that's the introduction. But let's address some complaints and pain points we have about this language, which is that it is an old language, and can you do anything with it, or does it have frameworks? Another classic point is that how do you use a library, third-party library? Because supposedly there is no package manager, and most important point is that our code safe faulted again. These are very common questions and like experience we have with this language. So our goal today is basically talk about these pain points and how we can kind of alleviate all these issues, and hopefully in the end your safe faults will be fixed if they exist. Okay, right. Let's address one of the most famous, like the most common complaint, which is that the way C++ testing is pretty old, and modern languages have a lot of nice new features. But I would say that the reason we think that is because we kinda don't learn the modern features of C++. So if you look into the standard libraries, the current library, and if you look at the library from like 10 years ago during the C++ 11, it has incorporated a lot of the great important, I guess, features that you find in a modern language. For example, type inference or structural binding. It has lambda functions typed, basically, unlike in C where you have just function pointers. So, and it also, unlike in C where you need to use the thread primitives of your operating system, C++ comes with its own box of asynchronous primitives, and all of these are part of the standard library. So we are gonna look into a few of them because just to familiarize ourselves with some of this stuff. Okay, I guess right. Let's look into some of them. So the tuple is like the most common library, common thing you can find in languages like Java or I guess Python, you can see this thing. But I would like to point into the second line, the way we can like access stuff from most tuple. You can do something like a structural binding. You can just, see like 3 variable, you just write it in a bracket, and then the tuples values are going to be imposed on those variables. And you can use auto, which is basically type inference, where you don't really need to like say what that thing is actually. The compiler is going to take care of that for you. So it's kind of like let in JavaScript or something. Right. Another thing is range-based looping. That is also very common. Unlike in C, you can do the you don't need to like use indexes to get into your array containers or map containers or whatever. So here in this example, we're trying to show that it's a map, and a map would have a key and value, and all you need to do to access them is to just write that, just auto, and then you have a structural binding of key and value, and you colon, and then you write the what the thing, the container you want to access, and that's how you can like access all the values. So that would mean that the index related issues that you might have in other in C, that won't be here. And another big thing C++ has is the lambda functions, and the way modern standard uses these lambda functions to do a bunch of very concise functions with these lambda functions basically. So like in this example, what we're trying to show is that we have in standard library something called any-of, which can like loop through a range of values, and it can see if a predicate is matching. So in this example, what we're doing is that names is suppose a string of array of strings, and then you are trying to see if any of them are empty. So the predicate basically does that line, that is bad line, that's your lambda. So what it does, it it is returning s.empty. It just checks if the value is empty, and you don't need to like think about what the type is. You can use auto for both the parameter name and your function lambda name, and then you just put it in your in this any-of function, and that's it. That's how you get it. You don't need to loop. You don't need to do any if check. Everything is done. Yeah, sort of like JavaScript basically. So if you want to do even better, you can remove the isBad and just call that lambda in that ranges function. That would also work. So it's a one-liner basically, right? So this kind of way of using lambda is very common. Another thing I would talk about is future. Future is new asynchronous primitives that exist in modern C++. You can have a job as a lambda, and that job can be a lambda or another function, and you declare it as asynchronously, and if you get it, then it will wait, and when it's done, it will get it for you. So it is kind of like async await in JavaScript, or any other, or Python, or whatever language you are familiar with, right? So these things are comes with the language, and it is just very easy to use. And if you look at modern languages, these kind of features, you can just see an one-on-one like comparison with these kind of features. Okay, now that we looked at some of the features, let's see some other concerns. For example, one of the big concerns that people have is with memory. Like, how do you do memory management with C++? So basically, we use new and delete when we learn this language, and nobody uses that. I don't think anybody used new and delete till like the last 10 years. So basically, the way you use it is smart pointers, unique pointers, and shared pointers. And the way it works is that when you declare these pointer containers, the heap allocation happens inside these containers. You don't really need to manage anything. You don't need to call anything manually. That means that there is no chance of you calling delete twice. Your code throwing before coming to delete, you're forgetting delete. None of that matters, because with this new model, when that object goes out of scope, that thing is going to get removed automatically. So this concept of like, grabbing a resource in a scope, and that resource going out of the resource getting cleared when going out of scope is called RAII. This is kind of like a replacement of garbage collection. So we don't really do that garbage collection, but we kind of sort of get some of the niceties of GC language. So this RAII concept is you can expand the RAII concept to other kind of resources. It doesn't have to be just memory. So for example, in this code, we're looking into a file function, the way you can get a file. So in C code or something like that, you can see that the way you do it is you use fopen and fclose. So as you can see, that leads to the same issue. You might forget to write fclose, you might write it twice and stuff like that. You might throw beforehand. But with the RAII version, you don't need to do any of that. You can just write if stream, which is basically means input file stream, and that's about it. Then you can access your things, and when this main function is going to go out of scope, that's going to get deleted. And this model kind of is familiar. It would be familiar to people who have worked with stuff like with in Python. Yeah, this is the same concept basically. So you declare it with, but in C++, it's kind of like you don't need to write something to invoke it. The libraries are themselves like that, right? So yeah, that's what you should use. That's the recommendation that we use when RAII APIs are available. We use RAII, and if they are not available, the recommendation is that you write a wrapper that you can use as a RAII in your other codes, so that you don't need to think about it all the time. Okay. Right. So now we can, this example is basically regarding some of the pain point people have. One of the most important thing in the modern development is JSON parsing. And I guess, if you look into any other modern languages, you can see that you can just parse a string array and then you can just access stuff. So in C++, there is a library called Glaze that lets you do the same thing. So if you just declare what the structure of your JSON is going to be, and you can just call read JSON, and then you can basically just get the thing out, and you can do a structure binding there as well. As you can see, that name and members, those two variables are basically reflecting team's name and member, and that's about it. You just call this read JSON function, and then you can get all the values out of there. Yeah, so it's so these kind of libraries are available, and you can use them without going through a lot of pain. Right. So okay, now that we talked about a bunch of feature stuff, let's talk about tools, because unlike other languages where you have this mandate of heaven from some big company, Google, for a goal or something like that, C++ is too old to do that. So you have like so many different tools, but the most common compilers are GCC, Clang, and MSVC. MSVC is only for Windows, but the other ones are cross-platform, so you can compile your code, anywhere with these compilers. And the debuggers are basically GDB, that is part of the GCC compiler toolset. And then there's LLDB. LLDB is a bit interesting, that if you're using a language that has LLVM backend, you can use LLDB to debug it, not just C++. So Swift or like Rust, you can use LLDB there as well. Okay, right, and obviously build system comes in when you're working with like big projects. So C++ has this cross-platform build system called CMake. You just write your CMake script, and then you can just declare all the stuff you need there, and you can just build it by one command called CMake build, and that's about it. There are other systems like Ninja and Make and stuff like that. These are like platform specific. You don't need to care about those because CMake kind of generates those things for you. So that's why it's called a meta build system. But it's a bit going too out there. But just think about it like CMake is all you need to learn to work with C++. Okay. Let's talk about something else, which is that tools to do memory profiling. Now, why do you need it? It might be needed because you are working with some library that are old. It might be a C library or something which doesn't really have this modern feature. So you might face issues. It might be that you are writing that code. It might be that, or maybe some colleague is writing that code, and you are like having pain fixing it. So you will have to use this kind of memory profiling tools. So the most reliant one is called sanitizers. So sanitizers are basically with this you can check a lot of different kind of issues like address, which basically does like address related problems like accessing something after it got removed, or like it might be a thread related issue like race condition and stuff. You can have a flag for that as well. So these are different flags, sanitizer flags. And what you need to do is that you need to compile your source code with these flags turned on, and then it will just spit out like if there is any error in that code when you would try to run it. In this example, if you look at it, I'm not sure if you can see, but what is happening is that we're trying to access that X array after it got deleted. So when you run it, what you are saying is that it is in one of the line, it does say that on line 4 it deleted, and it points you to where the issue is, and that can be very helpful when you are working on like large projects and not really understanding where the bug or the crash is coming from or something similar. So this is a tool that you need to compile your code with, but there are other tools where you don't need to compile your code with. All you need to do is to run your executable with this tool, which is called Valgrind. It's specific to Linux, but my colleague Ankon will talk about some of the Windows tools like this. So with this, you can get the same kind of output as sanitizer. The only difference is that it is a bit slower, but the advantage is that you don't need to compile your code with anything to get this output with Valgrind. Right. So these are the memory profiler tools. Valgrind also comes with thread-related stuff as well, just like sanitizers. And you can also use something called Massive to like look into frame graphs of your memory usage if you are, a visual learner, basically. Right. So now that we've talked about some of the memory tools, let's talk about how do we write code that is not going to have those bugs. So basically, analyzers, static analyzers, or LSPs or linters. So there are a few. Client ID is the most common because it's open source and it is part of the client project. And there is ReSharper from Visual Studio. That's also pretty good, I heard. So if you like integrate your IDE with client ID, you will get a lot of the problems you might have in your code, and it will help you write modern code. So for example, I have kind of pasted the same code in my editor, and it is saying that basically you should consider using a smart pointer, which is the right choice. So so when you are in the development phase, you can like catch these kind of issues very early. So now that but another thing that you can use it for is that you can just run client ID on any of your source file or header file, and then it will just give you this error stuff out in terminal or something. And it might be helpful when to run it in your CI/CD pipeline. The way it would work is that you can have a set of rules, client ID rules, and every peer that goes through, you can just check that if this is following the rules we set up, then the whole project is going to have a homogeneous vibe, I guess, and it will probably you can probably catch a lot of the issues that you might face later early. Okay. So package managers, one of the pain points, and most of people probably haven't really thought about it, but C++ made a lot of the C++ libraries. For example, apt libraries can be just installed via your package manager, like apt homebrew. So you just if you just put dev in the end, they would show up a lot of the time. But if you are like looking for something cargo like or npm like, there are some common package like VC package. This comes from Microsoft, and there are like 3,000 each package in their official repo. And the way you like install a library is just write that line, kind of like any other modern language. And Conan also does the same thing. And CPM is part of the CMake toolkit, where you can like turn any CMake project into a package by just using that. So yeah, these are like package managers you can use. We use Conan, but you have choice basically. VC package is also very popular, right? Now that we talked about some package managers, let's talk about some of the libraries, right? You might have let's talk about some libraries you might have used without knowing. So for if you are using another language, but it is regarding performance and stuff, it might be that it is using C++ in the background somewhere, maybe. So Node.js, for example, V8 is written in C++, and it uses SymDJSON, which is a JSON parser, very fast JSON parser library to like parse any of your JavaScript JSON code. Another thing is TensorFlow. That backend is also C++. TensorFlow is probably very commonly we use it with Python, but underlying it uses to Eigen, which is like a very scientific tool for metric stuff, and also Boost is a collection of libraries together, so you can call it a framework as well. So this also has a lot of scientific specific libraries. So TensorFlow uses both of these stuff. So and yeah, so we'll talk about Boost later. And Qt is a library that is probably used more heavily than any other ones. We'll talk. My colleague is going to expand on that. Right. Yeah. Let's talk a bit about Boost, because Boost is kind of like a suite of library that is very performant and is used in, I guess, I think from what I know that Node.js event loop also uses it. So, and we also use it for our in our project for some things as well. So some of the very common submodules of Boost is SEO. SEO is basically event loop stuff. So asynchronous stuff, what to think of. You can just write a lot of good asynchronous WebSocket related stuff with SEO. And if you want to write web server or client stuff, you have BoostBeast. And there are a lot of good libraries in Boost for doing stuff like histogram calculation, mean, standard deviation, and stuff like that. And also it comes with its own serialization, deserialization libraries. So whether it is XML or JSON, you can use Boost to parse them probably. The funny thing about Boost is that Boost is basically a precursor to the standard. So a lot of the stuff showed up on Boost that I guess stolen by the standard later. So if you want to see what might end up in the next standard C++, you might look at the Boost. Right. Now that we have talked about all the generic stuff, let's talk about some of the examples that are more closer to home, basically. So our project, our medieval project, we are a project using neural image stuff. So you can analysis, you can view MRI data. So we use two things. One is that we use a graphical rendering library called OpenInventor to render the data, but we also use Boost for doing some of the statistical calculation on the data, and we use Qt for doing some WebSocket stuff. And there is other scientific stuff like DCMTK. These are part of the C++. They're written in C++, and we use them to do some data parsing. Right. Yeah, that's about it from my end. I would like my colleague to start talking about his, use cases.
Yep, sure. Thank you so much, Arnold Bhai, for the wonderful explanation of the stuff we do at Node Information Lab. So I'm Onkun from Rely on Simulation, and I'll be describing what we use C++ for. So simulation, it's actually right in the name. We build simulation software for the drilling and lifting operations. And this is specifically for the oil and gas or energy industry altogether. And on the screen, you can see a few of the examples of the tools we build and the scale of it. So there are many requirements that we have, which make C++ the perfect candidate for our use case. And these pain points or these requirements are solved by different portions of C++. So the first major thing is graphics rendering. We have to emulate an entire environment. So we need lots of high performance graphics rendering. And C++ helps us here because with this language, we have a freedom of choice. So for example, if we want to deal with higher levels of abstraction with business logic, then we can use classes and object-oriented stuff. But if we want to dig deep and go under the hood and write performance critical code, or we need to access low-level graphics APIs like OpenGL and DirectX, we also can choose to do that whenever we want. We also have many physics and pressure and fluid dynamics calculations. These calculations must be deterministic, and they're also high performance. And for this, we use one of the C++'s libraries, which is Eigen, and I think Arnabhai also talked about it a bit before. We have also another use case, which is PLC integration. And what this means is we have to integrate with actual equipment on real oil rigs. So for this, we need this sort of low latency communication with industrial protocols like RS-485, for which, once again, C++ is the perfect choice. And finally, drilling and lifting. These have very complex user interfaces because there are multiple machineries and they must be operated differently. And there can be multiple users and multiple screens. So for this, we heavily rely on Qt, and we're going to actually talk about Qt later on today. We also use QML, which is part of Qt, and a bunch of other libraries like QWT, which is Qt widgets for technical applications. So before we jump into the library specific things, let's first talk a bit about the tooling on the Windows side of things. So Arnabhai explained about sanitizers and Valgrind on the Linux side of things. So contrary to popular belief, on the Windows end, we are not actually left barren. We do have profiling tools. And one of the, I think, better ones is actually built right into Visual Studio, which is its performance profiler. Now, the screenshot might be a bit funny because we're showing C# stuff, but it's the same set of tools, and we can use it for C++ as well. And it provides us with sort of basic and I think pretty good overall CPU profiling and memory profiling. But since we're building graphical tools, we'll definitely need the NVIDIA's Insight set of dev tools. So NVIDIA here helps us a lot by providing us with these three tools, which are NVIDIA Systems, which provides this sort of overall profiling, overall system profiling for CPU and memory. There's also Insight Compute. And now we actually don't use it really that much because it's usually used for CUDA profiling, and we don't directly interact with CUDA. Maybe Eigen under the hood, it uses CUDA. I might have to look into that, but we don't often use it. But the next tool, Insight Graphics, that sees very heavy use. And the screenshot is actually from NVIDIA Graphics. And you can see that we can debug frame by frame and see which shaders are being used, which draw calls are being made, and sort of optimize this really high performance code that we're building our renderer based off of. And finally, our friends at Intel also provides us with this tool called VTune Profiler. I personally haven't used it, but my teammate Ronnie Bhai has once or twice, and it's not that bad. It provides good CPU profiling. So as promised before, let's talk about the big library that sees very huge use cases across both teams. So Arnabhai's team and my team, we use it quite a lot. And it's Qt, pronounced as Qt and not Qt, which many people actually mispronounce it as Qt, but it's actually not that. So what's Qt? Qt is an application development framework, and it's used to create graphical user interfaces as well as cross-platform applications. So quite often when people talk about Qt, they relate directly to GUI, and that is indeed one of the largest use cases of this framework. But Qt has loads of other stuff as well. So this is a very simple example of the Qt 5.0 structure. The latest is actually Qt 6.0 and up. And as you can see, there are many components here. And if we were to put it into a single slide, that slide would have been over 20 pages long, I think. So instead, I'll just talk about it briefly and mostly show the GUI side of things. It also has web views. It also has rendering engines, OpenGL stuff. It also has like Bluetooth, dbus, and all the other stuff that our application framework must provide. So let's talk about the big part of Qt, which is to build graphical user interfaces. There are actually two ways we can build these cross-platform good-looking GUIs. The first way is Qt widgets, which is sort of the old school classical way of making desktop applications. And its new younger brother is QML, with which you can make these sort of fluent UIs with modern themes, modern UI, UX, material themes, good-looking animations and stuff. And we're going to talk about both here and let you be the judge of what you want to use for your next project, hopefully. So this is the simplest Qt widgets application. It's a blank window, nothing complicated. We have a C++ main function. We instantiate an object app of type Q application. We set a name for the window, and then we return app.execute. And that gives us this sort of blank, very boring, very ugly looking window. But don't get me wrong, this simple piece of code can be extended to build more full-fledged apps such as VLC Player, Wireshark, even several of the proprietary software that we use sometimes, like the Adobe suite of tools, SolidWorks, and so on. All of these performance critical apps, they do use Qt under the hood, although heavily modified and integrated into their own sort of libraries. But still, it's Qt anyway. But if we were to dissect these UIs, one of the most common ways of taking user input are push buttons. So as you can see, VLC has a bunch of buttons, Wireshark has a bunch of buttons as well. Now, in other languages, we handle button clicks or button events or any sort of events through callbacks. But I think Qt provides a very important architecture of handling events, which I really personally like. And I think every other framework should actually do it this way. So I feel very strongly about it. And that is signals and slots. This is one of the core ideas of Qt and what makes it so nice and very elegant to use. So simply, signals are something that you trigger, and slot is something that handles a triggered signal. So in this example, we have a test signal and a test slot. So when something emits this signal, it will be handled by the slot. And in our case, in this example, it will print something into the debug console using Qdebug. Now, this might seem very simplistic because we just have a signal and a slot. What's the use, right? So let's complicate it a bit more. You can actually have one signal that goes into multiple slots. You can also have a single slot handling multiple signals. You can also have a chain of signals. So you can have the first signal triggering the second signal, triggering a third signal, and finally getting handled by a slot. And it's very easy to form this sort of a bridge between the signal and the slot. And that's by using this connect function. And you also have these sort of multi-threaded apps, which uses signals and slots. So usually we use direct connections, but we can also have Qt connections. So think of a situation in which you have a threaded application. A classic example of this would be a producer-consumer scenario. So in this case, if we were just using plain C++ without Qt, we would have to do all sorts of synchronization primitives to make this work. But in Qt, it's very simplified. You just emit a signal, and you just have a slot, and you can have both of these running on different threads, and you can use Qt connections. So all of these signals will be queued, and they will be handled automatically by the slot, and everything will be synchronized, and everything will be fine. And there are no issues building multi-threaded apps this way in Qt. The easiest way to connect these things or to form the bridge between this thing is through the connect statement. We first give it the object of the signal, then we define the signal, and then the slot object, and then the slot that we want to connect the signal to. So how do we get the ball rolling? Well, we just emit this signal, and it will be captured and handled automatically by the slot. So the previous example was a bit abstract. Here is a more practical example of a push button. So in this case, we're actually displaying two very important things. One is we are redisplaying or showing the C++ lambda again. So in this case, in this example, the slot is actually a lambda. We don't need a separate function for that. We can just handle it inline. So we have a push button, and when the clicked event of this push button is triggered, we connect it to this slot, a lambda function, which actually just says clicked. So once again, this is also a very simple example, but in Qt's event-driven architecture, this is a very powerful concept, these signals and slots, because in our application, for example, when we do simulations, we heavily rely on this concept to simplify a lot of the logic. For example, suppose we have a machine and the machine's throttle can change. So we can increase or decrease the throttle. So I can have a signal called throttle changed, and I can connect it to a slot, for example, the fuel consumption. So you have this very elegant way of changing the fuel consumption based on the amount of throttle. And the code we can write gets to be very elegant as well and very expressive. So we talked about Qt widgets. There's another way to make modern UIs using C++ and Qt, which is Qt markup language, or QML. So here is one of the simplest examples with 2 buttons. And at first glance, QML looks a bit like JavaScript and CSS. So it's just sort of those 2 languages combined, you could say. This window has just a width and a height. Whether it's visible or not, we can set it as a parameter. We can have a title. We can have a layout. So just like HTML and CSS, we can have layouts here. We can have column layouts, row layouts. We can even have flex layouts, which is sort of like the flex box of HTML and CSS. So we have a spacing here of 2. It's centered in the parent. So in this case, the layout has the parent window. So it's going to be centered in the window. And then we basically just have 2 buttons here, an OK button and a cancel button. And we can theme it. We can do a lot of things with QML. And one of the things we can do is call JavaScript from QML. So these buttons, they can have an on-click function, and we can call JavaScript-like functions like console.log. We can also directly import JavaScript functions and call them from QML directly, which is the next example that's shown here. And furthermore, we have this thing, property binding, which is, once again, extremely useful. So for example, I have a rectangle and I want the height of the rectangle to always be twice or double the width. So when the width changes, it will automatically update the height and it will auto render it. So this is similar to most front-end frameworks where we see that they can sort of reload based on changes, like React, for example. So we also have property binding in QML as well. And we also have a way to connect to the C++ backend. That's also made very easy. And it's the same signal slots concept that we talked about previously. So I've here created a class backend. And as you will notice, we have this macro called QObject. And if we include this macro, then Qt's MOC, or the meta object compiler, will run so that we can import this type into QML and we can call it directly. So we have a bunch of slots on the backend side, OK and cancel. And on the button and on the QML end, we can just have the on-click signal connect to the slot and directly call it. And I think I will show an example later on from our application where we use this sort of architecture heavily for our application. So just to prove that this works, here is a very simple example. We have the simple app that we shown previously. So we can click on the button and it will get triggered. And this is actually using this sort of architecture where it connects to the C++ backend, and then that handles all of the business logic. So next, I would like to share my screen to show you the complexity of UIs that we can make using QML. So I'll very quickly just share my screen here. I think I might need to stop sharing the screen. So yeah. There we go. All right, hopefully my screen is visible. So these are the kind of UIs that we built using QML. So this is from our application that's running right now. And you can see just how flexible QML really is. So this entire trend graph, it's built using one of the libraries known as QWT, which is Qt Widgets for Technical Applications. And it has a lot of custom features. We also have stuff like this, where every single component is a customized QML. And we also have more stuff like this. These are the remote chokes, the MPD mud systems. We can even have rendering code inside of it as well. So I think we'll go back to the slide. and continue with it. Okay. So I'll stop sharing my screen over here. Yeah, in the Zoom.
Any questions, guys?
We will take questions soon. It's almost there.
Yeah, it's almost there. We do have a dedicated Q&A session here. Right, there we go. So we're back to the slides now. So yes, that's what we showed just now, the demo for our application and how we use QML. So the underlying point is Qt is much more than just GUIs. It has a bunch of core modules. We have other specialized modules, everything from networking to multimedia to concurrency, web engines, Bluetooth sensors, location, and so on. So we actually talked a lot about the specific library. So let's get back to C++, the main language that's today's topic. So we've talked about our use cases, and what about other uses of it in the industry? So it's heavily used in every major industries, which includes things like finance and banking, where in high frequency trading firms, where the requirement is nanosecond latencies, we need to use C++ because it's a compiled language and we have what's called zero overhead abstraction. Moreover, automotive is another big industry where it's used. So for example, Tesla's infotainment system, it's entirely made from Qt. And also things like automotive grade Linux that also uses C++. Moreover, gaming and the entertainment industries, one of the largest industries today, it cannot use anything other than C++ because it's cross-platform. This language is cross-platform. They can build for consoles. They can also build for desktop computers. We can choose lower levels of abstraction, as we talked about previously. So if you want to think about higher levels of abstraction, we want to talk about entities and stuff for game logic, then we can just stay happy with our higher levels of abstraction. And for performance critical code, we can jump down to the lower levels and we can directly access DirectX, Vulkan, OpenGL, and Metal APIs. Also, these are performance critical operations. So it's actually very hard to replace C++ for these sort of use cases. So what are today's takeaways? Well, what we learned today is that this language is definitely regularly updated. We do have standards. It's used in nearly every other industry that needs speed as well as precision. We also have an extremely rich set of frameworks. So we talked about Boost, Qt, Eigen, and there are many other frameworks that are used heavily all across the industry. We do actually have package managers, but the most important thing is we have freedom of choice. So people can choose what they want to use. We don't force something down people's throats. And initially we had this question of who even uses this language anymore? And the answer to that is everyone does across every industry. So with that takeaways, I would like to end today's knowledge sharing session. And I would like to extend my special gratitude to everyone here at Cephalo for being here for this long, hearing us babble about C++. And also especially a big thank you to our team members, Ronnie Bhai and Tamid Bhai, who also helped with the slides. And I think we'll move over to the Q&A section. So if you have any questions, you're free to ask them now.
All right. If nobody has any questions, I think we can end the session today. Any questions, anyone? Final call. All right, then I guess that's it for today. Thank you everybody for coming. Thank you both of you guys for the wonderful session. Have a great rest of the day. And I will make this session available in the repository shortly. Goodbye, guys.
Bye. Thank you, everyone. Bye.